All right, ladies and gentlemen, here we've got the notes for section 7.1, solving systems of two equations. So there's a couple different methods. We're going to start with the method of substitution. So a solution of a system, just a definition of two equations and two variables, is an ordered pair of real numbers, so x comma y. That is a solution of each equation. Now that ordered pair, the reason solution of a system, that ordered pair that you have x, y has to solve both equations at the same time. It has to be true for both of them. Now, if you're doing substitution, what the system, or using the method of substitution, we're going to rearrange one of these equations for one of the variables. So we're going to solve essentially either the top or the bottom equation for x or for y. It doesn't matter which one we choose. I'm actually going to solve the top equation for y. So I'd have to move the 2x to the right, which would give me this, and then divide everything by -1. So y is equal to 2x minus 10. Now, when you do substitution, you're going to substitute this 2x minus 10 into that y. So that's why it's called substitution. So this bottom equation becomes 3x plus 2 times 2x minus 10 equals 1. So 3x plus 4x minus 20 equals 1. 7x minus 20 is equal to 1. 7x is equal to 21. So x is 3. So now I know what x is, which I can now use x to find y. Now I can plug it into either this equation, or that equation, or that equation, or that equation. Any equation works. I'm actually going to use this one because this one's already solved for y. So y equals 2 times 3 minus 10. So y equals 6 minus 10. So y equals -4. So the solution is 3 comma -4. So this ordered pair works in both equations. If I plug it into the top, I get 6 plus 4, which is 10. If I plug it down here, I get 9 minus 8, which is 1. So this ordered pair works in both equations at the same time. Okay, so for example 2, find the dimensions of a rectangular garden that has a perimeter of 100 feet and an area of 300 square feet. So the equation for a perimeter of a rectangle is 2 lengths plus 2 widths. The area of a rectangle is length times width. Now, I know what the perimeter is, so this 2L has to be true. I also know what the area is. Whoops, I don't have it. So 300 equals length times width. So I have to solve one of these equations for one of these variables. I'm actually going to solve the bottom one. It's going to be easier. So for example, camera keeps moving. I can just divide both sides by L to get W by itself. So I have that statement. So now that I know what W is, I can replace this W with it. Now the one thing you have to be careful of is you do not want to substitute back into the equation you just solved, because that'll just give you a true statement. If I plug this W back in for here, I get 300 equals L times 300 over L. The L's cancel, 300 equals 300. It'll always be true if you substitute back into itself, so you don't want to do that. So 100 equals 2L plus 600 over L. Now the problem is I've got the L on the bottom, so to get rid of fractions because they're bad, I'm going to multiply everybody by L. So 100 equals 2L squared plus 600. Now this is a quadratic, so everybody needs to be on one side. So 2L squared. Oh, this should be 100L. Whoops, I knew I lost it somewhere. Minus 100L plus 600 equals 0. So now I need to solve this quadratic. Now I'm actually, to make my math a little bit easier, all these numbers are even, so I can actually divide everything by 2, which gives me this. So I can factor it, I can graph it, I can use the quadratic formula on it. Let's see here, can I think about what the factors are? Two numbers that multiply to 300 and add to 50. I don't know, so we're going to quadratic it. So -b plus or minus the square root of b squared minus 4ac is going to be minus 1200 all over 2a, which is just 2. So that's 50 plus or minus the square root of 1300 all over 2. So that would be, only 1300 would be plus or minus 10 root 13 over 2. So 25 plus or minus 5 root 13. So that's my length. I feel like I've done something wrong because this number is very, very weird. Let me go back and check my work. So, that's the problem. Okay, perimeter is 100, so 2 lengths and 2 widths. Area is length by width, so this has to be true, that has to be true. So divide the W, or divide the L across, we get that. It's 100 equals 2L plus 2 times that. So then 2 times that is 600L. Multiply everybody by L to make the fraction go away. So 100L equals 2L squared plus 600. Bring this guy across. Okay, so divide everything by 2 to get rid of the A value. Okay, so it looks like that's right, as near as I can tell. Let's make this a decimal to make it a little bit nicer. 25 plus 5 square root 3, 13. So this is about 43 feet. The width is 300 divided by the length. That's this formula I solved over here. So that's about 300 divided by 43. So that's going to be, we'll call it about, 7 feet. It's 6.97, but that doesn't round very nicely. All right, so there's our 2 answers. Probably should have carried that longer. This probably 6.97 would have been the better answer, just because that's too much rounding to go all the way up to 7. All right, so 3 here, solve this system. So these equations are both solved for y, which means we actually kind of shortcut this, because if I substitute this in for this, they just end up being equal to each other. Because if y is equal to this and y is equal to this, then they have to be equal to each other. So the top equation has to equal the bottom equation, because they're both equal to y. So we'll bring this guy over. So x cubed minus 9x is equal to 0. I'm going to try to factor it. So these terms both have an x, so I can pull an x out. This is factorable one more time. It's x plus 3, x minus 3. It's a difference of squares. So set each factor separately equal to 0 and solve. So there's the one already solved, -3 or +3. So those are our solutions. So we need the y values to go with them. So we have 0 comma something, -3 comma something, and +3 comma something. So if x is 0, y is also 0. And that ordered pair works in both equations. 0 equals 0 minus 0, true. 0 equals 3 times 0, also true. If it's -3, that's going to give us -9. And if it's +3, it's going to give us +9. So I got those so quickly because I just used the bottom equation. It's 3x. So it would work up here. -3 cubed is -27 minus 6 times -3. So -27 plus 18 is -9. If I plug 3 in, I get 27 minus 18, which is also 9. So that means this graph has these solutions. And if you actually graph these two equations, which talks about solving the equation graphically down here, we are not able to solve using algebraic techniques. In this case, we can solve this graphically. So if you look at these two equations, if I graph them, oops, 15 on that equation. There we go. X cubed plus 6, whoops, plus 6x and 3x, and draw the graph. Let's see, review window, initial, nope, standard, that's a good one. No, still doesn't really help. I think there's something wrong with my equations here. Oh, x cubed plus 6. That's why I'm not getting my right answer. -6. Draw. There we go. So If you see, there's 3 places the graphs cross. I have 3 solutions. That one's the -3, -9. That one's the 0, 0. That's the 3, 9. Most of your calculators can't actually solve those. On this Casio, if I press the G solve key, F5, I can search for intersections by pressing F5 again. So -3, -9. If I hit the right arrow, 0, 0. The right arrow again, 3, 9. So the same points I had up here. All right, the last method we have is elimination, which is my preferred method, especially if you have it look like this. So when you do method of elimination, your goal is to eliminate a variable. You do that by adding the 2 equations together, but before you do that, you want one of your variables to have opposite coefficients. So for example, in this, my x's are already opposites, so I'm going to make them go away. Now the number part has to be the same, which means I need to multiply my rows by something. So if I multiply this top row by 3 and the bottom row by 2, I'll have 6 and -6. So this equation becomes 6x plus 9y equals 15. This equation becomes -6x plus 10y equals 42. And now I add my columns down. X's go away. I have 19y. I eliminated the x's. And this over here is, 57. And then divide by 19. So y is 3. So I know y. Go back to one of my equations and plug it in to get x. So 2x plus 3 times 3 equals 15. So 2x plus 9, not 15, 5, equals 5. 2x equals -4. So x is -2. So my answer is the ordered pair, -2, 3. And that pair should work in both equations. If I plug it in the top, I get -4 plus 9, which is 5. If I plug it in the bottom, I get 6 plus 15, which is 21. All right. So example 5, solve this system. So in this case, neither of my variables is already opposite, but this is a single x, so it's going to be the easiest one to fix. So I'm actually going to multiply my top row by -2. And that's going to give my -2 in front of this x. So this equation becomes -2x plus 6y equals +4. Everything multiplied by -2. And the bottom equation doesn't need to be multiplied by anything. So I would have this. Now if you look, what happens though is that those cancel and those cancel. So I have 0 equals 8. This has no solution. 0 equals 8 is a false statement. If you looked at the graph of these two equations, they would never cross. They don't intersect. They're actually parallel lines if you graph them. Now, to graph them, you'd have to solve it for y. So this would essentially be y equals 1/3 x plus 2/3. This would be y equals 1/3 x minus 2/3. So the same slopes, but different intercepts, so they'll never cross. All right, let's try this one. We'll do the top row by 3 to make the x's match. So 12x minus 5y equals 6. Bottom row don't need to multiply. -12x, that should be minus 15. Plus 15y equals -6. Now, a similar thing happens here. Everybody goes away on the left, but also everybody goes away on the right. This equation is, what's it referred to? Can't remember the fancy. All real numbers, essentially. These equations are the same line. So any point that solves this will also solve this. There's an infinite number of solutions. All real numbers is a bad example. Because it's not, you can't use any number for x. You have an infinite number of solutions. Okay, so applications-y type problem here. So example 7, San Francisco and San Jose are major Northern California cities that are less than 50 miles apart. The table below shows that San Jose's population has been growing faster than San Francisco's. So San Francisco starts with more, ends with less. So San Jose has to make it up. Compute linear regression models for both cities. Okay. So we're going to use our x value is going to be years since 1980. Our y value is going to be the population. thousands. So I'm going to let my calculator actually handle the linear regression. So to do that on a Casio, you go to Stats, and then what I'm going to do is enter my list. You can't see it. There you go. List 1 is going to be my year since 1980, the time. So the first one is 0, 10, 20, 30, 35. 0, 10, 20, 30, 35. List 2 here is going to be my population. So 679, 724, 776.7, 805.2, 864.8. And then what I'm going to do is I'm going to calculate a regression line that is linear. Now AX plus B. So for San Francisco, y equals 4.94x plus 676, call it that. So that's my linear regression model. And then, so this is San Francisco. So I need to do the thing for San Jose. So just go back, replace your values for the population with the other ones, 629.4, 782.2, 894.9, 945.9, and 1026.9. And then recalculate. So this one has a slope of 10.65 and 653 was 654. All right, so there's my two equations. So use the population models, determine where they surpass, that's where they're going to equal, as well as the common population of two cities at that time. So when is going to be the X, the population is going to be the Y. But when San Jose surpasses San Francisco, that means they're equal to each other. So I just set my two equations equal. 4.94x plus 676 is equal to 10.65x plus 654. So bring all your x's to one side. So 4.94 minus 10.65. So this is negative 5.71x is equal to 654 minus 676, negative 22. So x is equal to 3.85 years. Now it's after 1980, because that's where x is measured in. So that'd be about, it's approximately 1984 would be the year. Population would be just plug that number back into one of my equations. So 4.94 times 3.85 plus 676. I just chose the top equation. Doesn't matter which one you do. 4.94 times 3.85 plus 676. So at that time, both cities have a population of about this. So 695,000 people in each city when they are equivalent in about 1984. So actually, if you notice, it crosses over. You should be able to tell somewhere between 1980 and 1990, because 679 to 724, this one's already more than San Francisco. So the cross point has to be somewhere in here. San Jose is below here, but above here. So it crosses somewhere between 1980 and 1994. Okay, example 8. Nybach Manufacturing has determined the production and price of a new tennis shoe should be geared towards the equilibrium point for this system of equations. The price P is in dollars, the number of shoes, X is in millions of pairs. Find the equilibrium point. So just where are they equal? So 160 minus 5X equals 35 plus 20X. So negative 25X equals negative 125. X is 3, so 3 million pairs. So, and if you want the price, that would be 160 minus 5 times 3, which would be 160 minus 15, or $145. That's the end of our section.